Thank you. Dr. Nakaiwa, over to you.
Thank you very much, Professor Majaliwa. I was here incognito, but thank you very much for inviting me to say just one word, just to greet the participants. Good evening, good afternoon, wherever you are joining in to this module. As Jolene has said, this is one of the modules under the ACRA program, and we believe that through such trainings, we can spread the need for addressing climate smart agriculture and climate information systems across the African continent. We welcome you to take heed and know that when we sow one seed in these trainings, we get a little bit more effects and we reap a little bit more as a continent. Thank you very much. And I do believe that our esteemed professors Kacho and Majaliwa will take us through this very topical issue that we have as a continent. Thank you very much, and I look forward to participating effectively in the meeting. Thank you very much.
Thank you, Des, for those kind words. So, participants, good morning, good afternoon to you. So today we want to share with you this particular topic on so someone is someone is disturbing
Kato, can you give us the hostship people making noise? Kato?
Okay, so this particular module is on clean energy options for sustainable agricultural productivity. One of the reasons why we actually selected this particular topic is that energy is very critical in terms of economic development of a given country for particular farmers. But this particular energy system contributes to can contribute to agricultural productivity, but it can also be a source of environmental issues. So the use of clean energy in powering agricultural value chain activity can not only enhance productivity, but also improve the welfare of smallholder farmers, but also maintaining the greenhouse gas emission very low. Unfortunately, most of our farmers are unaware of the existence of energy technologies which are clean and have limited access to distributors for their installation, parts and services. So adoption of clean energy will assist to reduce reliance on expensive or unsustainable energy sources like firewood, charcoal, and kerosene. So this particular module has been designed for undergraduate students, but also an extension workers who actively support farmers with information and advisories. So this particular training is supposed to assist people who are going to be trainers of undergraduate students, but also the extension, but also for those who want to learn some few things about clean energy. So the goal is to impact microeconomies and rural communities through promotion of cost-effective clean energy options for agricultural value chain productivity. So we have 3 learning outcomes. One is competencies in analyzing energy options in order to support farmers' decision on powering agricultural activities such as irrigation, greenhouse conditioning, food and feed processing and preservation. but also apply fundamentals, knowledge on energy generation, but also design, construct, and operationalize powering system on agricultural farm. So those are the three learning outcomes for this particular course. So we have 5 modules under this course. The first one, module 1, will talk about power system structure, primary energy sources and processing systems, where we'll get hydropower, wind energy, solar energy, biomass, and thermal energy. This, in terms of competencies, we are looking at people mastering the clean energy concept, but also be able to estimate the potential of existing clean energy. In terms of mode of delivery, we are looking at lectures, field visit, and video materials for people who are going to be teaching this course. Under module 2 on clean energy option for agricultural value chain, we'll discuss issues of inputs, production, local transport, collection, storage, handling, value-added processing, transport, logistics, and marketing and distribution, and end users. But in terms of competences, we are looking at capacity to select the best energy option in the different agricultural value chain. And in terms of mode of delivery, the teachers should be able to use lectures, field visit, and video materials. In terms of module 3, which look at the energy conversion devices, we are looking at 2 particular options. They say 3. One on from one form of energy into electricity, but also for direct to alternating current, but also from alternating to direct current. But in terms of competences, again, we are looking at people who will be able to select the best conversion devices on the market, and the mode of delivery should be lectures and video materials. Module 4 is on design and maintenance of these clean energy systems. So under this, we will discuss the design of selected power generation system, basically hydro, solar, wind, biomass, and geothermal, and biogas, but also construction of biogas system and operation principles, then storage, and then maintenance of selected clean energy on agricultural farm. So in terms of competences, we are looking at capacity to construct selected agricultural value chain energy generation system, maintenance, how to maintain the selected agricultural value clean energy generation system, and in terms of mode of delivery, we are looking at lectures, video materials, and lab practicals. So the last module, which is on energy value chain economics, we'll discuss cost and pricing schemes, but also comparison between existing options. And in terms of competences, those who will attend this particular course will be able to conduct economic analysis of the available clean energy in agricultural value chain, but also in terms of delivery, we are looking at basically lectures. So this course, if it's taken fully, the duration should be 2 to 3 months. The introduction to clean energy could take 10 hours. Clean energy for agricultural value chain, 20 hours. Energy conversion devices, 5 hours. The design, construction, operation, and maintenance of energy generation system in agricultural value chain, 30 hours. And then the agricultural energy in value chain economics, 10 hours. So you observe that we have put too much on the fundamentals, but also on the practical aspect, because the two will take 50 hours out of the 75 hours this course is supposed to be taking. So in terms of assessment, we are looking at written tests and the practical outputs for the design, construction, operation and maintenance of energy generation system. And all the rest is basically written tests. So in terms of days, basically we have planned that the introduction, which I'm doing, and the module 1 would actually take 1 day. We'll see how it moves. And then all the other will take, energy conversion system will take 2. And the second day, the third one will be on design, construction, operation, and maintenance of energy generation system. And then the fourth day will be just basically focusing on the economics. So we are 2 people, so myself, Majaliwa, and my colleague, Kacho Karume, to conduct this particular module. So I will basically start with the clean energy and go up to probably the fundamentals for hydro, and then I will leave my colleague Karume to move to the next. So basically, as I said before, the energy systems we have across the world have been designed basically in a conventional way as centralized power generation systems. So we have up to the 90s big plants to generate a lot of energy, and frequently these are being based either on fossil fuel or on hydropowers, and dispatched this energy to consumers based on relatively inflexible schedules. But this required fundamental changes if we look at the environmental conditions created by some of these structures. And currently we need to reduce on carbon dioxide emissions. And then particularly the use of fossil fuel becomes an issue. And people have now started moving into decentralized power generation system. And this is basically due to increased reliance on variable sources such as solar and wind power. So as we are advancing into transition under the current power system structure to the future power system structure, we need not only to identify mechanisms, but also to implement them by integrating more renewable energy generation systems. Because most of the structure before, as I said, were not integrating some of these renewable power systems. And basically, they presented at that time some limitation, but some of those limitations have been resolved over time. Now, so we have this current power system, and we want to move into a transition. And the transition means we are going into decentralized biodirectional system. So one case, in case the barrier is still maintained, then we'll basically go into failure. But if we are looking at disintegration in terms of synergies, then we are likely to be more successful. So if we look at the evolution in terms of power system structure, determinants of energy system have evolved through economics. People are looking at the economics. People are looking at the comfort of what the system is bringing. But currently, it's not only economics, it's the earth system itself. It's the society also people are looking at. Not only the comfort people will get, but also in terms of environmental effect of this energy system, but also in terms of availability of this system. So, as someone is teaching this course, basically, he needs to emphasize the two aspects. One, the issue of primary energy, but also the issue of secondary energy. Primary energy, the way it is defined, is basically an energy form found in nature that has not been subjected to any human engineering. It is energy contained in raw fuel and other forms of energy, including waste, received as input to a system. Some of these can be non-renewable, some can be renewable. The secondary energy system is a carrier of energy such as electricity. These are produced by conversion from primary energy source. And the conversion efficiency is very, very important because if you move from one energy to another, you need to reduce on the losses. And this can be checked using specific tools. So you have here presented the different form of energy. So you can have nuclear, you can have thermal, you can have chemical, gravitational, it can be wave, it can be tidal, it can be wind, it can be mechanical, it can be electricity, it can be also be radiation from the solar. It is easier to move, for example, from nuclear to thermal, and then from thermal into mechanical, and then through electric generators, we move into electricity. The same can be done on a gravitational and hydrotidal system, where we can easily move into mechanical if you have a rotor, and this can actually be converted through electric generators to get electricity. So the same can be done for thermal energy. Thermal energy can, through heat engines, you can actually have it as mechanical and move it into electricity through generators. The same can be done for chemical, either coal or oil or gas or biomass or hydrogen. We can actually move it into electricity. So the same for wind. Wind can be through mechanical processes, and using generators, we can also have it as electricity. The same for solar. So solar can actually be converted into heat and through heat engines, mechanical and electric generators, we can have it in electricity, or we can also have it as electricity through photovoltaic. So this is basically a summary of what the fundamentals is going to be focusing on. So this is very important element for a teacher to start with introducing energy systems. So let me take you through the hydropower. Basically, for someone to teach this particular component, he needs to answer two questions. What is hydropower? And how does hydropower works? So in simple terms, hydropower technology generates power by using elevation difference. That has been the major principle in most of the system up to the 90s. And people have been building dams or diversion structures to actually do this. But now we actually know that we can actually do it without big elevations. So the principle is that the energy of flowing water is used to make turbines start rotating. And the rotation of the turbine will generate the electricity we need. So this is one of the clean and renewable and efficient source of energy that rely on water cycle and gravity to power homes and industries across the world. And there are so many across the world. So this is one of the examples of an hydropower. So we have different types of hydropower. And the different type of hydropower are based on the size, operational methods, and then the storage capabilities. So these three factors, size, operation methods, and storage capacity, actually determine how water is used to generate electricity and how energy production is managed. So now we have number one. This is an example of an hydropower near our town, Ruzizi, across between DRC and Rwanda. So this is an impounded hydropower, what we call a reservoir-based hydropower. So this is basically built based on the dam to store water in a reservoir, and electricity is generated through the height difference or elevation difference through the turbines. So we have, in this case, so many of these examples. For example, in Ethiopia, we got, that's the Grand Ethiopian Renaissance Dam. And then we have Aswan High Dam in Egypt, but there are so many other dams across the continent built based on this particular principle. The advantage of this is basically reliable power generation, multiple purpose reservoir, but it also has disadvantages, which include high construction cost, environmental and social impact. So as we are talking about this, people need actually to know the principle of a given hydropower, the advantage and disadvantage, because these are going to be the criteria for selection, in addition to the three other factors we listed before. Then we have a runoff river hydropower, which actually utilize the natural flow of a river, and where people have created diversion through a small channel or pipes to make sure that the turbine are used to rotate and generate electricity. So basically, these are small scale dams, or they are small scale hydropower plants. And you have so many of these across the continent. The advantage of it is that one, they have limited environmental impact compared to the big dams. They are cost effective for small scale generation. But their disadvantage is basically that the flow varies with season. And the fact that we have limited storage for energy regulation. The third type is the pumped storage hydropower. So the picture here actually shows you that there is a big reservoir, but water is actually pumped in another place for storage and can be used basically or released basically when the peak or the demand is the highest. So the advantage of this particular system is that it provides energy storage and grid stability, and it balances renewable energy sources like solar and wind. But the disadvantage is that we require to have 2 reservoirs. And that will mean a lot of investment. But also, you have actually to foot the bill to have the 2 and put the infrastructure together. The fourth one is the micro and small hydropower. This is very, very important, especially for agricultural system. And this require minimum infrastructure. So, and again, they can be categorized into 2. The micro hydropower, which give you up to maximum of 100 kilowatts. And then you have the small hydropower, which give you between 100 kilowatt and 10 megawatt. So you have several of these systems all over the continent. The advantage is basically that they are ideal for off-grid rural electrification. So you don't need to be on the national grid to actually construct this. You can do it yourself, and the technology is very, very easy to put in place. And then 2, it has low environmental impact. The disadvantage is basically that the energy output is limited, but also the fluctuation due to seasonality, which can affect the performance of these particular category 5 is basically the in-stream hydropower, which is basically using the kinetic energy of the flowing river. So this example shows you a system. They put the turbine into the water, rotate, and it's connected to another system outside, which carry the electricity. So the advantage of this particular system is that, okay, we don't need too much. We don't need a dam. We don't need too many infrastructure. We just need to have the turbine. We use the tidal flow and generate electricity. So there is minimum disruption to the ecosystem, but it also presents disadvantages. So the location has to be suitable with a permanent flow and continuous flow. But again, the energy capacity is limited. So the last one is offshore and tidal hydropower. And here, basically, this one is used for oceans, where tidal systems are put in place, which can actually collect the flow, the energy of the flowing water, to rotate the system and generate power. So this can also be done for the waves, as water is undulating. We can also capture the same energy using the same principle. So the advantage here is that, of course, the energy is renewable and predictable source. The energy, we have high energy density in terms of tidal regions. And then the disadvantage basically is expensive and technologically complex. You need to fix all this system in the sea, and then limited cost areas. So this table actually summarizes what I've been talking about, and this is very important for the person who is teaching to actually compare the different type of hydropower, having their description, their advantages, and key limitations. So there are several challenges for hydropower development on the continent. One is high capital investment cost. Two, environmental and social concern. Then climate change coming in as more fluctuation in rainfall and change in land use affecting the runoff in the different streams. And then the prolonged drought also affecting the flow of the different streams. Then also the issue of infrastructure. We have seen that hydropower need a lot of infrastructure, but also the issue of political and institutional barriers. Some of these streams are cross-border, and you need countries to actually meet to agree to put an hydropower project on the river. So what is the potential for Africa? What are you going to do? Can Kato assist us to close some of those people? Kato, can you close everyone, please? Now, Africa has a lot of potential in terms of hydropower. It is actually estimated at 350 gigawatt. But only 11% of this potential is currently in use. Of course, the continent has among the biggest dams in the world. But some of these dams are not fully used. And these, we can get them in Central Africa, we have them in East Africa, but they are not optimized. We are not using them fully. In Central Africa, we have, for example, on the Congo River, we have the Inga Dam with a potential of 40 gigawatt. We have in Uganda several dams on the Nile. We have them in Tanzania and Kenya. We have a big dam in Ethiopia, the Grand Ethiopian Renaissance Dam, with 6.45 gigawatt upon completion. But we also have in West Africa, the Niger River Basin. We have in Ghana, Akosombo Dam, with a potential 1 gigawatt of electricity. We have in Southern Africa, in Zambia, Mozambique, Angola, and Zimbabwe, with the Zambezi River playing a critical role. So we have the Kariba Dam on the Zambezi River, supplying electricity for Zambia and Zimbabwe. In North Africa, we have in Egypt with Aswan High Dam. So this map here shows you the distribution of the different hydropower dams across the continent. And we can actually see a concentration around the East African region, but also around the central and western coast of Africa. We have very limited dams in North Africa and in Southern Africa. But then the question is, how do we integrate some of these to actually resolve the issue of power on the continent. So if you want to estimate, there are several ways of making estimation, but here I'm actually putting based on the key principle. So we know that energy is equal to power times time. So if you want to get power, of course, you need to get energy over time. And the power can actually be estimated using the system efficiency, the density of the water, the gravitational acceleration, but also the flow of the water and the head or the difference in elevation. So that is in terms of hydropower. So I want to request, Prof. Karume, do you want to go into the wind, or you want to start from the soil?
Yes, what I can say, when it comes to hydropower, we should develop, as it is mentioned in the course, a way of simply, how can we simply estimate the flow as well as the height. For the flow, we have developed two different methods. When the flowing water is not too big, someone can use the bucket method, which is very simple. You estimate the time it takes for a bucket to fill, knowing the volume of the bucket. Another way of estimating when the river is too big is to use a floating method. Floating method, using the time, you use just a clock, you estimate the cross section and the height of the water, and you can be able to get the flow to put in this formula. And it will be simple to estimate that, because we are doing all this to empower students or a extension worker when he's in a given environment in the village or on the farm, to be able to estimate by himself using simple tools the potential of a river or any flowing water. So having said that, I can now move to wind energy. As Professor Majaliwa has pointed out, in this course we'll be all the time trying to answer two questions. I mean, the trainer, the teacher will be giving this course. When it comes to any given energy, the two questions will be, what is wind energy? What is solar energy? What is hydropower energy? What is geothermal energy or biomass energy? What is it? And the second question, how does it work? And that's what I'm going to go through in this part of the course. What is wind energy? Wind power. Wind power is obtained using the wind speed, blowing wind. And the blowing wind will meet the blades and make blades rotating. And according to different design, you can have uneven blades or even blades. And each of these blades can have an advantage as well as disadvantages. But as we are going to see later on or in the course, people suggest use an even number of blades for stability reason. Because when you have an even number of blades, the stability is not very well. So when you have these blades, they are connected to a rotor with a turbine. So the mechanical energy from the blade is converted to rotation by turbine, and the turbine is, through a rotor is linked to a generator. And the generator is the one to produce energy. So at the end of the day, we have a rotating movement, which is linked to a generator, and the generator can produce energy. It can be either a direct current or alternating current. Whatever the case, if your system is using current, direct current or alternating current, it will be possible to convert each to another one. That one will handle it tomorrow. So the generator at the end of the day will produce electricity, which will be used on the farm or in the village for people to power their system. And generally, when you are talking about wind energy, we have two big systems of wind. The first one is horizontal axis wind turbine, which can be used, and the other one is vertical system, vertical axis wind turbine. I'm wondering if I have to go in details through those different types of wind turbine, or I have just to cover because the details can be found in the text, which is available on the Profaron platform. But we can just emphasize on the horizontal axis wind turbine. You have the axis is parallel to the ground, and as the other system, the axis will be vertical or perpendicular to the ground. This one, the horizontal axis wind turbine, is the most used, is the most common use for large scale power generation system. And when it comes to small generation, people are using vertical axis. We have different types of those horizontal, and I don't think I will go through those different systems. But let me quickly see what are advantages and disadvantages of this type of horizontal axis and vertical wind turbine. What we can emphasize on is mainly advantages and disadvantages. What are advantages of wind energy? The main advantage of wind energy is the fact that it's a clean energy. Remember when Professor Majaliwa was introducing the fundament of energy, we said we have two types of energy, renewable energy and non-renewable energy. And the wind energy is among renewable energy. It is cost-effective types of energy. I'm talking about different advantages of wind energy. It's cost-effective types of energy. You can easily harness it as a technology, and it is cheap, and it can give work to different people. Those are mainly the advantages of this type of energy. So Majaliwa, can you move? Because I'm covering quickly advantages and disadvantages of wind energy. Can you please move?
Mhm.
So, what of turbine? One of disadvantages of wind turbines for energy production, one, you don't have wind all the time. And at the end of the day, we are going to see to cover that disadvantage, people require to use a hybrid system. So you connect solar and wind turbine. We see that at a later stage. That's one. Secondly, you need a big land, because to have a plant, you need a big land. And at the end of the day, when you have to come to the coast, it becomes very costly when you see the opportunity cost of land compared to energy. For region where the density of population is too high, it becomes very difficult to avail a big chunk of land for wind production. Third, it can impact local biodiversity. Mainly, birds can be killed using when they know the blade, rotating blades, because as they are rotating at a high speed, birds, they don't realize that it's a moving object, and they get killed. Okay.
Kato, can you
Yes,
assist us to close people? Go ahead, Prof.
Okay. The other disadvantage of energy is sometimes it can create noise. Technology advancement, people have been able to reduce the level of noise. And we can see that there is a big potential of wind energy in Africa. Mainly currently in Africa, you can find about 83 installed wind farms, and more than 140 projects planned for wind energy production across Africa. And we think in the next coming years, Africa will be able to generate a big amount of energy, which can cover about 2% of energy produced on the continent. The target is to come to produce something around 300 gigawatts by 2030. And I think people will meet that target. You can mainly have this potential in Angola, in Chad, in Mali, in Ghana, in Sudan, in Niger, in Madagascar, in Zambia, and other countries like Malawi, and so on. Because we are going to see, when you are estimating the potential of wind energy, you have the wind speed which is coming in. So to be able to produce wind energy, you need to have enough wind speed so that you can get more energy generated. The formula to estimate the potential wind energy is half area covered by airflow area times the density, air density, times the wind power 3 times time. So if you want to play around energy produced by wind, you can play either by increasing the speed or increasing the airflow area. But the problem with airflow area, we have limitation. Because if you go very far with the area flow area, it means you have blends too long, it's going to create problem with the stability of the system. So at the end of the day, we remain with the factor V, which is the speed, wind speed, which is wind speed 3 times. And when you are on area where wind speed is not too big, you can increase it by increasing the height, because there is a relationship between height and wind speed. If the height is high, you have also the wind speed, which is increasing. So you can do that by using tall, very tall, structure. When you have a structure, very tall structure, you can use them to increase wind speed. And by increasing wind speed, you can increase the same time the energy which can be produced. The curve shows clearly that at a point, because even if the wind speed is increased, at a certain point, at a given point, you reach the saturation. Wind speed is kept, not wind speed, but the energy is kept constant. That's why in the system, when you are mounting the wind system, you have a gear which can help to increase the wind speed, and the same system can help to keep constant wind speed over time. So, as I was saying, advantages of wind power you have is cost effective. It can be, it can create jobs, because when you are mounting the system, you can employ hundreds of people to make it work. It is a clean fuel source, because no carbon dioxide emitted, no methane emitted. Wind is a domestic source of energy, and it can be sustainable. It can be built on farm or on existing ranch. That are some of advantage of wind speed. As I was saying, given that wind speed is not constant over time, people have developed hybrid system. Hybrid system combine wind and solar at the same time. And let's say, for instance, during daytime, solar is very good. So you use a solar panel to charge batteries, and during evening time, when solar has gone down, you can use wind, because most of the places of sites, most of sites, you have a wind, which is very good during evening and night time, and the solar is very good during day. So hybrid system can be very well used and integrated, because you, at the end of the day, you use the same batteries, you charge them using solar energy, and you charge the same batteries using wind energy. That is hybrid system. So what are challenges of wind power? Challenges of wind power, we have, it must, sorry? Okay, I was saying, wind power must compute with conventional generation sources. When I'm talking about generation sources, I see directly hydropower, the cost of hydropower is normally the least cost of energy. So currently, wind power is not yet competitive with hydropower. I said the other challenge is land. People should be having a big amount of land, and sometimes it can compete with the price of land for building or for other business. So people have to see the cost opportunities to compute the opportunity cost of the land when you are using it for energy production or for other business. Wind resource development might not be the most profitable sometimes in some countries. For instance, in Eastern Congo, where the density population is high, it's very difficult to dedicate the land for wind energy instead of for building. And the other advantage, turbine can cause noise and cause pollution, noise pollution. Wind plants can impact the local wildlife, mainly birds. But there is now a technology which can send the birds away from wind just by producing a noise which is harmful for birds, and the birds can be kept far away from that one using physical principles. Going to challenges of wind power, again, the wind has limited speed in some sites. That limited speed cannot allow production of high energy. But I said we can go about that by going in height, because as height increases, the wind also increases. That is a possible way of increasing the speed. And I can also point out that production of wind energy is a long-term process. And that one, you cannot just wake up and say, I establish wind speed. You need at least 3 to 6 months to make it work. It's not like a generator, just a generator. You can wake up and at the same time you produce energy for use. That's a big problem for wind power. And other challenges for wind, we have it requires large area, as I was saying, and it is costly. Wind production is costly compared to the other, for instance, for hydropower or for solars we are going to see tomorrow, and we are going to go through that one. So I think that's what the teacher can emphasize on when he's teaching wind energy. He has to emphasize on advantages, on challenges, on the potential to measure, and how to come out of those ones. So Majawi, I think I can stop there, and you can get some questions of participants. If there are no questions, now we can move ahead and go to solar energy.
Okay, so let's give a chance to, maybe Jolene will assist us to identify the people who want to talk, then we can, and they give us their questions.
Yes, Professor, I would request those people who would want to ask questions to raise their hands so that we can call upon them to unmute themselves and ask the question. I think people are okay. I'm not seeing any. I'm also not seeing any chat.
Okay.
So I think
Okay,
we can
then.
proceed.
So we, Prof. Karumbe, do you want to go into solar?
You want to go to solar?
No, you can go. No, go to solar. No
Okay.
problem.
So we have to move to solar energy. And the two questions come again. What is solar energy and how is solar energy work? Let's say we have two ways of producing energy from solar. By heating water, when water is, let's say that is a term way of getting energy from solar. Heating water, after heating water, you can generate vapor, and the vapor can run a turbine. A turbine is connected to a generator, and the generator can produce energy. That is the first way of producing solar energy. But we have also another way of producing solar energy by using photo cells, photovoltaic cells. Those are the two known ways of generating solar energy, either by heating water or another liquid, or by using photovoltaic cells. So sun provides more energy to the earth in an hour. And we are going to see, if you want to evaluate, to estimate the potential, you need to know two main parameters. One parameter will be the sunshine hours and the solar radiation. Those are the main parameters to be known for estimating energy from solar energy. So we can have a big amount of energy produced by sunshine. For instance, in Uganda and in eastern part of Congo, the solar radiation is something around 7 kilowatts per hour. 7 kilowatt hours per square meter. It means for each square meters, it's possible to harness 7 kilowatt hours for 1 square kilometer. So, and people have realized that it can be a solution for the future to go against CO2 emitted by this fuel, fossil fuels, because the potential is very, very high. On the continent, in 2023, people are planning to produce more than 165,000 terawatts of solar energy. How is solar energy generated on the earth? Solar energy is produced using two primary technologies. The first technology, which is well known, is using photovoltaic system. Photovoltaic system using solar panel, which are made up of some solar cells using semiconductor, and which are exposed on solar radiation. Those cells, they convert solar radiation to energy, and that energy can be taken using a converter and so on to battery. And that energy is generally a current, direct current form of energy. So at the end of the day, after panel solar has produced as converted solar radiation to electricity, the electricity is converted by the converter to direct current. A direct current is stored in the batteries, and batteries can store that energy during nighttime when solar is no longer there. And in the system, if you are using alternating current, it's always possible to convert direct current to alternating current. That one will be covered tomorrow, how we can do that using transformers and so on. The other system of producing electricity using solar energy is solar thermal system. How does solar systems work? These systems, they capture the sun heat instead of light. For photovoltaic is light which is captured. For this one, we capture the heat, and we have solar collectors which collect the heat using mirrors and other system to focus that sunlight to something which store water or any other liquid to heat that water, and that water can produce steam, and the steam can drive a turbine. And when a turbine is running, it can be connected or linked to a generator, electricity, and the generator which can produce electricity. And the electricity can be either current generator, direct current generator, or alternating generator. That is how we can produce solar energy, either by using photovoltaic system or solar thermal system. In one case, we capture light, and in the other system, we capture heat. What is photovoltaic technology, and how does it work? So we have about 7 steps to make it work. The first step is you mount the structure, mounting structure. That is the first step. You mount the structure which is going to receive solar panel. So you after mounting the structure, you build a integrated panel, voltaic panel, which is going to receive, because you can put it either on a roof, or you can just mount any structures which can accommodate those solar panels. The easiest way to do it is just to put it on the roof, and the roof can play the role of mounting structure. So after considering the roof as a mounting structures, you take your panel solar on the roof, you put them in a integrated a system, let's say a metallic structure which is going to get those systems. But for some reason and some countries, they can also make a building which is integrated with panel voltaic system. Let's say, for instance, the wall, different walls can be in can be can receive panel solar for producing.
photovoltaic system دي
Sorry,
photovoltaic system 58 نيوه 57 حزب
come again.
شكل مقال
I can
Prof.
kindly mute that person.
Just continue, Prof. Karum.
شو photovoltaic system ማለት قال مالي فوتو لايت يقع ها
I don't get you.
Oh, just continue. The person is talking to another one. Just continue.
Okay, I said you can have some building integrated panel voltaic system. The easiest way of doing it is using, as I was saying, roof.
Okay.
And very simple to mount them on the roof. So after getting your panel on the roof, you fix them very well, but you should take care, you incline, you how can I say that? You don't let them at 0 degree, but you take a apparently there was a problem of network. So I was saying, you incline them so that they can be self-watching when there is a rain. The angle should be between 2 degrees and 15 degrees to be able to expose them for a long time during the day, at least 8 hours a day. Otherwise, if you take more than that angle, you reduce the exposition time. So the component of the system is solar panel, as I was saying, which contains multiple and made from semiconductor. You can either those ones the current technology.
Can't hear you.
When some you can't hear me.
No, just go ahead. Go ahead, please. Go ahead.
Do you get me? Do you hear me?
Yes,
Hello?
we can get you. We can get you. Go ahead.
Now we can hear you. Go ahead.
Prof. Majaliwa, can you hear me?
Yes, we can hear you.
Yes. Yes.
Yes, we can hear you, sir. Yes.
Hello, Prof. Karume, are you off?
So when sunlight cells, it can electrons which will create electricity, current electricity, and the physics behind that is well known, and it has been known for a long time, since the period of Einstein. So it's it's a well-known technology. So the theory has been developed with Albert Einstein for around 1921. So if we have can be converted later on using a converter. So all 95% of all the solar cells are composed of silicon, because they are silicon, because they are cheaper than germanium as a semiconductor. So having said that, so when you are mounting your solar panel, you should pay attention to one thing. You have to clean all the space around when you are mounting your solar panel. You have to cut trees if there are trees around. All trees, because just a part and the other part is it's going to break. You no longer, you have to pay attention to that. A solar panel, you have to make sure that the is exposed with to be applied when we'll be to kill it. The second part of solar panel producing after converting solar is using converters. Converters which are going to convert electricity to the energy, the photo energy to electricity, direct current electricity. And now after converters, now we can take it to batteries. And sometimes before batteries, you can also use, you can convert them to current, to alternating electricity. So this is how solar panel is working. That's how it works. And the number of solar panel should be determined according to the power needs. If the power need is too it's high, you have to increase the number of solar panel you are using. If the demand of energy is low, you reduce the number of solar panel, as well as trees to convert.
Kato, can you close some of these people out?
All the
It's a cap wears host ship.
But can we ask the
Based on the
person?
type,
Kindly mute yourself, Yadanos. Yadanos, kindly mute yourself.
so based on the types of crystal used the solar cells, we can classify them as monocrystalline silicon cells, polycrystalline silicon cells, and amorpho silicon cells. Those are 3 types of we can have. So no need to go into details on those ones. They can be found in the course which has been developed. So now, how can someone estimate solar energy? To estimate solar energy for solar panel daily, you can use the equation which is we take into account solar irradiance, which is kilowatt per square meter, as I said, and that one in Congo and Uganda, it is estimated being about 7 kilowatt per square meters. You have to consider area of solar panel, which is in square meters, and you have to consider the efficiency of the system, which is around 18%, and you have to consider the peak sunlight hours, and that one can be in hours per day. So when you consider those parameters and you multiply them, you can get the energy with the potential energy which can be obtained from solar panel. So solar radiation levels varies by location, by season, and by times of day. So when you are designing your system, you should be able to design your system using, for instance, 2 days without sunshine. That will give you the number of battery to consider when you are doing that, because we have seen that solar radiation is it varies with location, it varies with time, and it varies with season. For instance, during dry season, the sunshine hours is high compared to sunshine hours during the wet season. So the efficiency, system efficiency, include different losses. Loss with solar panel efficiency, loss in inverters, and loss when the panel solar is exposed out and the dust has covered a part of a solar panel. That's why I was saying we should take 2 degrees, angle 2 degrees to 15 to allow those the dust to be cleaned up with rain when rain is coming out. And finally, the efficiency is also a function of shading. And that one I said, when you are installing your panel solar, you should clean the area to avoid shading, because if a part of a solar panel is covered by shading, it may kill it. So weather conditions also, when there is cloud, it can also impact the efficiency of the system. So during cloud time, the efficiency may go down. That's the role of getting a big storing system, because when you have those climate conditions, let's say when you have rain coming out, when you have cloud coming, the system should be able to run for a long time without being exposed to solar radiation. So the map which is there is showing the energy potential of solar energy in Africa. Majaliwa, can you go ahead with the slide showing the map? Please, Majaliwa, go ahead with the map. Okay. The map is showing area with high potential and area with less potential in Africa. But as you can realize, all Africa has a potential of producing solar energy, either by photovoltaic or by using thermal solar system. So in Africa, it should not be a problem producing energy using solar energy. So current solar energy production, today you can use solar power to in different solar power can be used in different applications. Among those applications, you have those who are very simple and those who can be complex. You can use solar power, for instance, for pumping water, for drying, that one will be covered tomorrow, drying agricultural product, and so on. So you have also large-scale projects which have been developed in different countries, like in Morocco, in Egypt, and other countries to produce a big amount of energy. So let me go now to advantages and disadvantages of solar energy. The first advantage of solar energy, it's a clean and no polluting type of energy. So not only it's a renewable energy, but in addition, it's a very clean source of energy and no polluting source of energy. No CO2 produced, no methane gas produced, no other greenhouse gases produced. It is a renewable source of energy. Solar cells do not produce noise, and they are totally silent. So no pollution by noise, no pollution by gas emitted. They require very little maintenance. That's a big advantage of solar panel system. The only maintenance you are going to see at the end of the day is cleaning the panel solar, which can be done, let's say, twice a year or 3 times a year, depending on the site where you are. when you are in dirty areas, you have to clean regularly. But if there is rain coming, let's say 3 times a month, there is no need to clean solar panel because rain is going to clean solar panel. So among advantage, we have a long-lasting source of energy because solar panel, you have at least 25 years of lifestyle of solar panel. So during 25 years, you can use those systems. The only system which can, let's say, with less lifetime is batteries. But today we have batteries which can last for 10 years, 15 years, and 20 years. So among advantage, we can keep the long-lasting source of energy. And no need of fuel. There is no need to buy fuel. There is no need of fuel supply. So you forget about that problem of fuel supply because the only fuel you need is solar. So among now disadvantages of solar panel, you have it cannot produce a big amount of energy unless you go for a complex system which will require a big amount of land, and sometimes you need, let's say, 50 hectares, and that can be a big problem of solar energy. Solar power cannot obtain during night time, and that's why there is need of a hybrid system. You combine solar panel, solar system with wind system so that you can power morning, day, and night, day. And if you don't have a hybrid, you need now to have a big storage, which becomes costly at the end of the day. So no air pollution and need of large area of land when you need to produce big amount of energy. So I think, Prof. Majaliwa, I can stop there for solar panel system. And after that, we can, if no question is asked, we can go ahead and cover biomass system. So let's give a chance to participants to ask questions.
Okay, so let's get the questions. Jolene can kindly assist us to check if we have questions.
Yes, I have one question here saying, is solar energy long-lasting relative to other methods, hydropower and wind energy?
Okay, so that's question number 1.
Yes, I got cut off, so I lost my charts in the...
Oh, okay.
Yes.
Okay. Is there any other question? So the question is solar energy long lasting.
Yes.
Yes, Prof. Karume, you can answer that one if you can.
Yes, I can ask a question.
Go ahead.
Of course, if you compare solar energy to, let's say, for instance, hydropower energy, because hydropower energy can last for 100 years, it's about concrete. But when you come to maintenance and cost and so on, why I'm saying that solar energy is lasting, because you have about 25 years, you don't change any spare for solar panel. Solar panel can last 25 years, no need to change. Converters can last, if well well mounted, it can last 25 years. And I say today with the technology, advanced technology in batteries, you have batteries which can last 15 years to 20 years. That's why I'm saying you have the old system without changing any spare, because nothing is moving, and it can last for about 25 years and nothing has been changed. But hydropower can last 100 years, but before the 100 years, you have to change spares for about 20 times, 40 times. That's a big problem.
Okay, so I think, is there any other question?
The side panels are now relatively cheap. The major challenge is the lifespan. I think it's just a comment.
Yeah, that's a comment.
Yeah.
And the systems are, the spares are now around. Yeah, so
Yes.
yes, so
There's another one. There is an emerging concern about pollution from solar and wind components. Solar panels have a relative lifespan of 25 years, and discarded components are becoming an environmental concern. What do you have to say about this?
Come again?
yes. So the question is, the materials used for solar panels after the 25 years becomes a challenge, especially the silicon, because when silicon enter the water, it becomes a huge problem because the water become very polluted and with a lot of environmental and food chain related issues. So, but the other part, of course, is the recycling. So there are so many ways now of recycling those materials. So we don't just need to take them to leave them to go into the environment. After 25 years, we can recycle the materials and avoid that the pollution take place. Is there any other question?
Between the three types of solar, monopoly and alpha, in terms of efficiency.
Yeah, so you are, this is the one, the different type of, the three types, these three types.
Yes,
what is the question?
Which one is the best in terms of efficiency?
Kindly repeat the question.
Between those three types of solar, which one is the best in terms of efficiency?
Generally, people use the monocrystalline silicon. That's the most popular system on the continent and elsewhere.
Which energy does give more power, or what?
What is the question?
They say which energy does give more power, or what?
Which energy
gives more power, or what?
I don't get the question. Which energy gives more power?
Which energy does give more power, or what?
So which source of energy, or does he say, is it which source of energy
Yeah.
or which energy?
He says which energy, but I think maybe it was which source of energy.
Okay, but I think, yes. So 1 joule created by biomass is the same 1 joule created by solar, is the same 1 joule created by hydro. So maybe in terms of, if we have a given source, if we have a hydro, for example, as we say, there are different types, and those different types will have different power generated. If you want to get more power with solar, so you need to increase on the size. You need to increase on the number of panels. if you want to get more energy on the wind, you need to increase on the size of the wind park and put as many stands of wind devices for you to create the amount you require. So I think that's what we could say. A joule created from one source is the same joule created from the other.
And in addition, what I can say, remember, we have seen that we have about 5 types of renewable energies. Let's say hydro, solar, biomass, geothermal, and the wind. On farm, it is rare to find those 5 different types of energy available. So what the student or the extension worker will do, when you arrive on the farm, you have first of all to see what is the energy available on the farm. So if you have hydropower, if you have solar, and if you have wind, now you are going to see what energy has a high potential. But not only you stop from the high potential, you have also to consider the maintenance cost, the installation cost, and you have also to consider all the economics around that. That will be covered, how you can compare and make a choice of which energy you choose. But as Majaliwa has pointed out, 1 joule produced by biomass or biogas, it's 1 joule. But you have to see which energy is available on farm, and that one will be the one to be developed. And if they are available, you have now to carry out economics analysis to be able to choose one of them.
Okay, thank you, Professor. We kindly request those participants, one who's supposed to be speaking, to kindly mute themselves. In particular, Jean. Yeah, thank you. You can proceed, Professor. Yes, Salma.
There was also a question stated earlier by Owino Wycliffe. He said there is an emerging concern about pollution. A minute. Okay, there is an emerging concern about pollution from solar and wind power components. Solar panels have a relative lifespan of 25 years, and the discarded components are becoming an environmental concern. What to say about this?
I think I answered that question. A silicon, when released into the water, generates silica, and silica becomes a big concern, especially for water. And it's one of the key indicators of pollution in water. But as I said, after 25 years, those materials, either from wind or from solar, can actually be recycled. So it's actually an issue of management of waste. So if we manage our waste properly, then there is no major problem with those components. Is there any other question?
Yes,
I think that answers the question for
the one of preventing. Yes, the one of preventing environmental degradation. I think you've already answered that one. So I think we can hand over to you now.
Okay, so yeah, thank you very much, Jolene, and thank you, colleagues, for the nice questions. So let me quickly go through the biomass. So we are going to answer the same questions. What is biomass energy? How does biomass convert it to energy? And what are the advantages and disadvantages of this type of energy? So generally, when we talk about biomass, we are looking at organic materials that we have in our systems and which are generated through natural processes. This could be plant material. They could also be other forms of labile systems. But generally, if you look at the growth of vegetation, we actually know that this growth is linked to carbon through a number of processes and through the cycle of carbon. And generally, there is a life for these particular materials. At a given time, some of these materials have to die and can be used otherwise. So we have, in terms of potential biomass, we have a lot of agricultural residues. We have residues from forest materials, from wood. We have residues for animal waste. We have residues for municipal and solid waste. And we have also crops which can be actually used for this purpose. Now, in terms of forest, forestry potential, we know that Africa has a lot of these forest materials, and we have several basins across the continent which have sufficient amount of forest materials. In type of livestock, we know that Africa has a lot of livestock. We know what is happening in Ethiopia, Somalia, in Kenya, in Uganda, and other countries across the continent, Malawi, Namibia, where animals are actually kept. Then we also know that there are also those crops which are used for energy generation. Those ones coming from jatropha, those ones from sugarcane, and other for feedstocks. We also know that Africa is also having a lot of these mega cities, and a lot of waste is being generated from those cities. So we know that biomass can be renewed, and in that case, it stands to be renewable energy. Though we also know that the expansion of the different land uses may actually be a threat to this biomass, and therefore could actually create an issue of sustainability of some of these materials, especially from those plantations and forestry systems. So the advantage of biomass is that biomass is a very clean energy source. We have some of this waste, degradable waste in the landfill, and they can actually be used for this purpose. There are emissions from biomass, but in terms of their potential to create bigger impact in terms of greenhouse gases, we know that it's very low. If we have some of this biomass, certainly we can actually go away from some of the sources of energy. The biggest challenge is basically the issue of efficiency in terms, if we compare with other sources. The second one is an issue of combustion, which require a lot of space. And the third one is the issue of degradation. Either forest materials, when they are cut, generally, this is vegetation degradation, and if you generate a lot of these waste, also can contribute to environmental degradation. So it actually means, to some extent, the use of this can also be having some harmful effect on the nature. So now let's go to geothermal. The geothermal is basically energy originating from the heat stored within the Earth's surface. And this heat can come from the Earth's surface and can be actually harvested from the Earth's surface as residual heat and can be used for domestic and industrial activities. How is it used, and how is geothermal energy produced? How does geothermal energy work? So how is it used? Geothermal energy power plants convert the steam which is coming from the soil, and this steam can actually be used to generate electricity using turbine and generators. We can also get it as direct heating. So just to heat homes, to heat industrial facilities. And we can actually pump the heat. So there are different systems for doing it, as we'll see in the next slide. So basically, what we need is to identify the suitable areas. There are specialized techniques for doing it, and identify where we can actually have sufficient geothermal heat. So we can also do extraction, but we can also convert the heat into electricity using turbine. So I've talked about this. So we have three different types of system we can use actually to generate energy from geothermal. So we have the dry steam power plant, which is the first figure on the left. So once you have drilled, you have produced a well. So the heat coming from the within the soil can actually go into the system here where we have the turbine, and that heat will make the rotor start rotating, and that mechanical energy of the rotor is actually converted into electricity through a generator. Then the cooled water will now go back again, injected back into the earth, so that we can maintain the same amount of water without extracting anything. So the second one is a flash stream power plant. In this case here, of course, you still have the same well, and water is, the hot water is going into a tank. An opening is created to make sure that there is pressure to actually enter into the turbine and create more velocity for the turbine to rotate, and this is translated into energy through the generator, and the cold water goes back into the earth. The third system is the binary cycle power plant, where another liquid which can actually fuse faster or go into generate high temperature before compared to water is actually placed before the turbine. And in this case, even with relatively low temperature, you have sufficient pressure which goes into the turbine, and the turbine rotates and generates power, electricity on the other side. So we have a different type of reservoir depending on the temperature. You have the high temperature system, which goes to about 150 degrees centigrade. Then you have the moderate temperature system between 90 and 150 degrees centigrade. And you have the low temperature system at less than 90 degrees centigrade. So the first high temperature is actually good for power generation. If you have 90 to 150, then you have to use a binary power system. And if you have less than 90 degrees, it's basically used for heating and heating houses. Then the other part we need to consider is basically the volume of this particular geothermal reservoir. So how much steam do we get from these geothermal systems? So the other part we need to consider is basically the porosity of the rocks. So for the heat to come out of the soil. There are different also other parts we need to consider because for heat being mass times the heat capacity times the change in temperature. So we need to know the heat capacity of either the material you want to put in the binary system or of the liquid around these reservoirs. The other aspect,
Majaliwa,
of course,
Prof. Majaliwa,
yes.
It's 4. I suggest we stop there and we proceed tomorrow.
No, give me some 5 minutes. We could finalize it, then we restart tomorrow. So we need to look at the recovery factor. How much of this particular energy can be recovered in all time? Then we also need to look at the thermal gradient, how the temperature is changing with depth, because that will actually tell us something about sustainability. And then the reservoir lifetime. For how long can we exploit this particular geothermal system? How do we estimate the heat generated? So this is basically one of the formula which can be used. What is important for you to get the total thermal energy? You need to get the volume of the reservoir. We need to have an idea of the porosity of the reservoir. We need to know the density of the thermal fluid into that. Generally, it's very close to the density of the water. Then we need to know the specific heat capacity of the fluid, which can also be very close to that of the water. The density of the rock, close to 2,500, 2,700. And then the specific heat capacity of the rock. And then the average reservoir temperature, and then the ambient temperature. So those different factors put together will give us an estimation of the total thermal energy required. So the issue is to look at also the recovery to see how much we can recover when we actually we are using it. And basically the recovery factor don't go beyond 25%. We also need to have an idea of how much power can actually be generated from that heat. And again here, this will depend on the conversion efficiency. So the most important thing is to know what is the technology we need to use to actually convert the geothermal energy into electricity. And it's rarely to get systems or fish technologies which goes beyond 20%. And the reservoir lifetime generally is less than 50 years. So there are also simplified methods for someone to determine the thermal energy output. So there are this particular software which can be used, Homer, Geostar, and TAF2, actually to help make an estimation of the potential energy. If we look at the distribution in terms of distribution on the continent, we can actually see that the Eastern Africa present the highest potential. The Eastern African region present the highest potential of this. And then the part of Morocco, which have sufficient potential for geothermal. Other places is basically moderate to low potential. What are the advantages? Generally, the emissions are very low for geothermal, though we know sulfur may be one of the issue coming from these systems. They are cheaper than the conventional type of energy. Unlike other renewable energies, that solar, it is constantly available. And wind, so compared to solar and wind, you have it generally available. So what are the disadvantages? The geothermal plants can only be operated 100 to 90% of the time. You have the flash and the dry steam power system. Those one emit more than the fossil fuel. So, and we need to consider that one, as we said, and nitrogen oxide and sulfur. So we need to look at that one in terms of emission. For the binary and hot dry rocks plants, we don't have gaseous emission. And the geothermal plant do not require a lot of So despite being very expensive, being inexpensive, geothermal sustainability and environmental issues need to be considered. They are located generally where we have areas of tectonic plates, boundaries. They may be cheaper than fossil fuel, but it requires a lot of exploration and drilling on this site, which can actually be a bit expensive. And as I said, the geothermal plants release hydrogen sulfide, and this can be a problem, especially.
Professor, I have one question.
Yeah, I'm going to finish. So that can actually be a problem in areas where these systems are. So basically, those are the key for the five source of energy we have considered. Let's leave the other one for tomorrow. But if you have questions, kindly go ahead.
Thank you, sir. I am Mr. Honoré Irenga from Evangelic University of Africa, UEA Bukavu. My question concerned what the composition of turbine, which concern geothermal power plants. How to avoid the risk of nickel poisoning contained in the turbine of this geothermal power? Because if we have a longer exposition, we can have what we call a cancerogen AIDS. Thank you, sir.
Okay. Okay, thank you. So is there any other question?
Yes, we have a number in the chat.
Yeah, let's get them.
How can we avoid the consequences of lead poisoning caused by the prolonged use of solar panels? And how can we ensure that our customers are protected?
Can you repeat that question?
How can we avoid the consequences of lead poisoning caused by prolonged use of solar panels? And how can we ensure, lead, how can we ensure that our customers are protected?
Is there any other question?
Yes. Let's see. I think that's the only question.
Okay,
that's the only question.
Yeah, if I will start with the question of Virenge. His question was the issue of cancer related to the use of geothermal. I think, Irenge, is that the question you asked?
Yes, I asked how can concerns avoid the risk from the nickel compound, because nickel is a metal which can be, what can I say? In French, you can say originaire de quoi? Provoque le métaux lourd. Comment?
Oui, bon, posez la question en français, s'il vous plaît. Il n'y a pas de problème.
Oui. Comment on peut contourner les conséquences liées à ces métals, surtout que la turbine là, est composée d'un alliage de nickel ou de titane, qui sont deux métaux lourds et qui peuvent causer le cancer à une longue exposition.
OK. Je vais d'abord répondre à la question en français et puis traduire ça en anglais. So let me first answer the young man in French and then I will come back to English. English, yes. So, les systèmes, c'est un système fermé, comme tu peux le voir. Donc, l'eau chaude entre dans la section de la turbine et l'eau qui est froide, refroidie, est réinjectée dans le sol. Donc, les dangers n'est pas là en termes des effets sur les humains si on n'exploite pas l'eau dans le réservoir. Donc, si on n'exploite pas l'eau qui se trouve dans la surface, dans la profondeur de la terre, ces problèmes ne se posent pas. La question, c'est comment on va gérer ces déchets. Une fois qu'on veut détruire les systèmes. Je crois que c'est là où se trouverait la question. Donc, c'est encore un problème de gestion des déchets. So let me repeat the same in English for people to understand. So his question is basically the risk of the turbine, since we're actually exploiting a lot of this water, which is underground water, which can actually have heavy metals and can affect the turbine. And this, according to him, may actually have an effect on human health. My answer is simple. This system is a closed system. Water comes from the deep part of the earth, is entering the turbine, and water is re-injected back into the groundwater. So at that level, I'm not seeing a human interaction between with the heavy metals, which could actually be in the turbine. The issue will actually come when we want to decommission this. and say, okay, this is now, we want to replace it. And that again becomes an issue of waste management. So that is the question for
Irenge.
Irenge.
Thank you, sir.
So now for our colleague who was talking about solar pollution and the lead poisoning. Again, as for Irenge, this is the same issue of waste management. Of course, lead can be a problem for solar panel. Even as we said, for silicon, can also be a problem for solar panel. But again, is how do we manage the residues or these materials when they are not used or when they have expired? How do we handle it? That again becomes an issue of waste management.
And
So,
in addition, Majaliwa, in addition to that, are using more batteries, not using lead, but using lithium. But whatever the case, there's a problem also of waste management will come later, but lead is more and more avoided and replaced by lithium. For current density, because it's more dense, and also to avoid the environmental impact of lead.
Okay. So is there any other question?
I think we can stop there and resume tomorrow, Majali.
No, let's see if there are any other question so that we don't go with. But anyway, if there are more questions.
No other question, Professor.
Okay, good. Thank you very much. So thank you once again for everyone for attending this. Let's meet tomorrow. Tomorrow we will finalize we'll summarize what we have said, and then we go into converting devices. Once again, good evening to everyone.
Thank you, everyone, for being part of this training. Let us meet tomorrow at the same time. Thank you and bye.
Bye.
Thank you very much. Goodbye.
Okay, bye.
Thank you. I don't know who is the host. Please don't close the chat for now.
I think I'm the host.
Okay, just hold on. I want to make sure that the chats are. Who is recording? Because it seems like Ekepu is the host.
Is Ekepu the host?
So, okay. Done.
Okay.
Okay, Prof, you are the host. You can end the meeting.
Yes, let me come.
Prof Majaliwa?
Hello? Yes, please. Hello? Nicha Gandhi. Eh. Eh.
We don't hear any sound.
Wano tereroha.
Hello?
Tereroha. Wana tuwa tereroha naba. Yo kantari litisha.
No sound. No sound, Mr. Radley.
Hello.
We don't hear anything.
Okay. Oh, yes. Yes. But people have been talking too much. We wanted you to lock them out. No. What you do, design your system. When, as soon as people come, they are locked. You get it? So we only give them permission to talk. That's why I was calling you, sir. Yeah, thank you very much.